Teachers have a lot of different ways of asking students to do trigonometric values without calculators. The method I advocate is the two triangle method, where you just remember some particular values of triangles. Okay, with both triangles, we're drawing them in the unit circle, so they're going to have a radius of 1 on the unit circle, so that means they're hypotenuses. What's the plural of hypotenuse? Otherwise, those are both going to be 1. And one is isosceles, so that means it's going to be 45 and 45, which means the side lengths are the same. And the only way to make that happen is if both sides are square root of 2 over 2 because of the Pythagorean theorem. A squared plus b squared equals c squared. And the other triangle to memorize would be a 30-60 triangle. And this will cover all those typical values we want students to know in the unit circle. What's opposite of 60 always needs to be square root of 3 over 2. What's opposite of 30 needs to be 1/2. Okay, with those triangles in mind, let's draw 7 pi over 2, the angle of 7 pi over 2, which in other words is 105 degrees, right? So we're going to pass 90 degrees. Remember, this is your initial side. That's where you start drawing your angle. So here's about 45 degrees. Here's a full 90 degrees, so 105 is right here. So this isn't actually one of our special triangles if you make a reference triangle with the x-axis, because you're going to have, that's 105 degrees here, then this is 85 degrees in here. Sorry, 75. So that doesn't meet one of our special triangles. But what you can do instead is you can break this up using the sum or difference identities. Cosine of 105 is the same thing as cosine of 45 plus 60. Look, we have special triangles to help us figure out what cosine of 60 is and what cosine sine of 45 are. Okay, and there's other ways of doing this. You could say it's cosine of 180. No, that wouldn't work. Cosine of, I don't know. Maybe there's not another one. Okay, well, 45 plus 60 is 105. If you think of another way, it's still going to work as long as you use the correct formula. So this corresponds to the sum identity of cosine, where it says if you have cosine of an angle x plus an angle y, that's the same thing as cosine of x. Here, I'll type it out. It's a little neater. That's the same thing as cosine x cosine y minus sine x sine y. Okay, so if you have two angles being added together inside the argument of cosine, then you can rewrite it using this formula down here. Okay, put that right there. So that's what I'm doing here. X is 45 and 60 is our y. So I've got cosine, I'm doing cosine of 45 times cosine of 60. Subtracted by sine of 45, sine of 60. And those are ones that I can figure out using those reference triangles. Right? Because cosine of 45, draw where that lands. 45 degrees from initial side to terminal side is right here. And you always make your angle with the x-axis, because x is the argument. That's what you're plugging into things. But we're doing cosine of 45 means that we have a 45-degree reference angle. And so this is square root of 2 over 2. This is square root of 2 over 2 by those triangles I just drew over there, if we make it inside the unit circle. And cosine is the adjacent of the reference angle. So this side divided by the hypotenuse. So this is square root of 2 over 2. And do the same thing for cosine of 60. Draw your 60-degree angle. Make a right angle with the x-axis because we need right triangles for trig. And what's opposite of 60 is square root of 3 over 2. So that's why it makes it real quick if we memorize some particular values. And so this is 1/2. Okay, so if you want cosine of 60, you want the adjacent divided by the hypotenuse. So cosine of 60 is 1/2. And then sine of 45, we've already drawn that reference triangle. The opposite divided by the hypotenuse, that's also square root of 2 over 2. And then sine of 60, down here is our reference triangle for 60 degrees. What's opposite over the hypotenuse would be square root of 3 over 2. And there we go. The rest is just fraction work. right? You can multiply straight across the top here, so you get square root of 2 over 4 straight across the bottom. And then over here, square root of 2 times square root of 3 makes square root of 6 over 4. So our final answer is the square root of 2 minus the square root of 6 over 4. That's how we do that trig value of cosine of 7 pi over 12 without a calculator.